I'm John Ruttenberg from Alchemy, and we'll be presenting today on the Robin system for publicly available information, threat sensing in support of DoD, CBER, and IOW. I'm joined by Diana Hinton, our CBER and IOW analyst, who will be doing the demonstration at the end of this short briefing. Quick introduction into Alchemy. Alchemy is an innovative advanced technology solutions company. We specialize in big data, AI, analytics, publicly available information, modernization, and digital transformation, providing primarily IT services and commercial off-the-shelf software. We're a privately held company founded in 1997, headquartered in Washington, D.C. with approximately 100 personnel. You can see some of the emblems here of the different DoD and intelligence community, as well as other government organizations we have supported in the past. So the problem and opportunity we're addressing is the Department of Defense's strategic deterrence, tactical security, and CWMD related mission, countering evolving chemical, biological, radiological, and nuclear threats posed by state and non-state actors using asymmetric attacks and weapons of mass destruction against U.S. forces and our allies. The production and employment of CBER and WMD are human-generated processes and thus leave a large trail of evidence in both human activity and natural phenomenon signals. So that leaves the core challenge to U.S. forces is to identify these evolving threats as early as possible to get integrated early warning in support of the CBER defense mission. The Alchemy Robin solution to this enhances and informs the operator with alerts, Alchemy generated quad charts and dashboards with interactive visualizations to provide the operator with easily digestible contextualized insights informing the CBR&D decision-making process. Specifically, it is designed to enhance but not replace the operator by reducing the time spent manually sifting through large volumes of publicly available data. By building a large volume of CBER events and the noise surrounding them, we compile a corpus of activities, events, and trends, and then analyze them and train machine learning models to generate alerts. This allows Robin to highlight faint signals and enabling command integrated risk reduction decisions left of boom. Specifics on the Alchemy Robin platform. It's a software as a service in the cloud, conducting robust PAI collection. It's highly secure and developed using DevSecOps processes. The analysis in the models is done with integrated artificial intelligence using natural language processing, named entity recognition, and machine learning. For the collection, we non-invasively parse through social media, news, blogs, dark web, and other data. The analysis detects faint signals and illuminates threats in near real time. The next step is we enhance those alerts using CBER and IOW analyst tradecraft. So this is the person in the loop, delivering contextualized, curated content and analysis. The infrastructure of Robin is highly portable and scalable and capable of integrating with CBER and IS and other DoD systems. Characteristics of the system is that it's a web-based application built to gain insights from PAI. We provide IOW alerts to CBER operators through readbooks and analytics dashboards, enabling CBER and force posture decisions based on real-time information. We are currently aligned in the POM with Capability Development Package 2. We meet the key NRIDs that you see listed here for IEW and open source early warning, and we're aligned with the CBER IEW campaign effort, meeting U.S. Air Force items number 1 and 2. Robin now analyzes a monumental amount of PAI and parses it down significantly to meet a very specific and narrow criteria, in this case, CBER and IEW events, rather than sending out countless automated early bird type alerts. So Alchemy focuses the information even further by incorporating analyst tradecraft to deliver contextualized, curated content and analysis. So the net and so what of the problem. Robin also provides a unique blend of machine learning and the analytics augmented by human subject matter experts to provide the most focused, useful, mission-ready products. Notably, the Robin alerts, because they are publicly available information, do not present identified events as fact, but rather indicate that something is occurring and being discussed in the realm of PAI. Then the CBER community subject matter experts take that indications and early warning information and use other national resources to validate the information and determine if it resolves a critical information gap, thus allowing commanders to be informed quickly and make appropriate force posture decisions based on near real-time information. This visual gives you an idea of how much we neck down the information we collect. Over the last year, we've collected 1.3 billion records in our collection system. The collection filters then necked that down to 22 million records, which were fed into our machine learning models. Those specific machine learning models identified nearly 13,000 anomalies, and those 13,000 anomalies were analyzed by our analysts to deliver nearly 200 alerts via read books, spot reports, and quad charts. So that's 1.3 billion records in the world, in the PAI world, coming down to approximately 200 alerts. The DoD benefactors, as you can see on this slide, are at the tactical level, the operational level, and at the strategic level. The box at the top here are the current models we have that are operating. We have 12 models running right now, covering European, primarily Russian focused, on forces as well as hazards broken out into chemical, biological, and radiological and nuclear. We as well have the similar systems looking at China for the other models. Potential new and additional models are listed here and cover the rest of the world from North Korea and Iran to broad Middle East and Africa, other Indo-PACOM countries, dual use CBRN technology, CBRN precursors, event risk assessment, as well as policies and treaties. So as we transition to the demonstration portion of this presentation, I'm going to show you one of the slides that we've put out recently. And this is the format that we currently send our alerts out in via email. This particular story of the items that we normally put out. So in this case, it came from our Europe CBRN Forces attack model. And it was about satellite imagery indicating that Russia had increased the length of one of their runways at one of their air bases by approximately 1,000 meters. So the synopsis of the story was that there'd been an article posted stating that satellite imagery on the 13th of August revealed that Russia had increased the length of the runway at one of their air bases on Alexandra Land Island from 2.5 to 3.5 kilometers. And then we included a picture over in the top right quadrant. The IEW analysis is the so why is this important part. So according to the article, the increased length of the runway allows for accommodation of any Russian aircraft to be used at the airbase. And this expands the capabilities of the airbase. However, the real important part was, okay, they have a lot of air bases. Why is this one particular one important? What we discovered by researching it was that this particular airbase is less than 600 nautical miles from the North Pole and almost 1,000 nautical miles from the northern coast of Russia. So clearly that gives them a different location from which to launch strategic type CBRN assaults, as well as changes the dynamic and dwell times for anti-submarine warfare aircraft operating in the Arctic region, which as the sea lanes melt has become, again, a very important strategic location for operating submarines as well as commercial traffic. So for another story that we recently alerted to, I'll pass over to our CBRN IEW analyst, Diana.
Okay, so this story, we received a low-level alert in the system on 25th August 2020. So this was interesting because it was a lone BBC article that made a connection between the poisoning of Russian opposition leader Alexei Navalny and the Sergei Skripal poisonings, because the toxin the German doctors had announced were part of the same inhibitor group, which is linked to the Novichok family. So the interesting thing here is not just that it was on August 25th, a week before an official announcement, it was a Russian BBC article, and it was the only article we found at the time talking about these connections with the Sergei Skripal poisoning previously. So again, that was considered a low-level alert because of the terminology and the volume and velocity from the system. Now, moving on September 2nd, 2020, approximately a week later, Germany made the official announcement that Novichok was in fact was in fact the reason for the poisoning of Alexei Navalny. That was what the toxicology tests showed. So the previous slide, we detected that a week prior to this. So we have all of a sudden gone from a low level threat to a high level threat. And that was based off of the volume and velocity, which the graphic on this slide in the upper right hand corner shows. That at 1330 on the chart, there was barely any reporting going on in the system. Then all of a sudden at 1340, 10 minutes later, there were several records in the system that increased by 1400 into over 1100 results. So the speed that the news broke and spread across is what helped to trigger that high level threat. Now I'll pass it back to JJ.
It's important to understand how we get to that threat ranking matrix so you understand where that threat assessment is coming from. It's basically a three-part analysis. The initial part comes out of the Robin system, which is a measure of the anomaly strength. It's 5 levels from low up to severe. The second ranking comes out of the Joint Pub 3TAC11 assessments and definitions on threat probability from 0, where the entity does not even have the capability to employ CBRN weapons, up through high, where CBRN weapons have been employed and another attack is potentially imminent. And then we added a 5th level, which is hazards, which means they have already been used and they are present in our operational area. Those two are then combined using a standard threat or risk matrix to come out with threat rankings from low to extreme, with low being very minor risk and unlikely to occur, all the way to extreme, which indicates an imminent severe threat to operational forces. Our SOP is that we put these out based on the level of the alert. So extreme alerts would go out within 1 hour of internal notification, all the way down to low-level alerts, which would be sent out to the client within 24 hours. Robin's CBRN mission IEW impact is providing CBRN IEW of potential threats to U.S. forces. It's informing DoD strategy, policy plans, operations, training, and doctrine for CBRN Defense Program Campaign Plan for IEW. We provide situational awareness to assist warfighters in detecting, denying, and mitigating predefined threats and hazards, providing decision makers with better and more timely information, thus solving a critical mission need by improving CBRN IEW threat sensing and aiding CBRN hazard detection. So with that, I will turn it over to Diana to give you a demonstration of our current system and the updated system that will be rolling out in the first quarter of next year.
All right, so to begin the demonstration, I will show you what our current user interface looks like. So once you log in to the application, you'll be presented with a list of dashboards to choose from. So we'll go to this first one called a landing page. So once you select the dashboard, this is what it will display. It will have a list of the models across the top, along with a line and bubble chart showing alerts over the last 24 hours. And there will also be a pie showing you the breakdown of the alerts by severity type: low, moderate, high, critical, and severe. So that's what we see right now, and this is how we generate the read books. Considering this is very data forward, data heavy, we would like to now show you what we are working towards in the upgraded user experience. So the new user experience, upon logging in, will have all our readbook stories easily accessible by putting the latest readbook story on the far left-hand side of the screen for you to read with the full text version. Now, in order to see the threat matrix, we can click on this medium alert level up here, and then it will display the graphic of the alert level. Now, if you wish to review another story that had happened previously, we can go to this middle section and then click on one of the tiles, and the story will then be displayed for you in the full text version. Similarly, we can click on the low level alert button to display the threat matrix. Additionally, if you don't feel the need to read the full text and are curious as to what the threat matrix says, on the smaller tile, you can click the alert level to display that. Now, drawing your attention to the right-hand side of the screen, we do have a filter section. So if there's a particular topic or story or country you wish to choose from, we do have a set of filters to search from: keyword, date range, topics, area of responsibilities, countries, and severities. The data portion is still a part of the new user experience to where we can click on the analyst dashboard. This will look a little bit different in the first iteration. It will look like what I showed you previously. It'll have the same exact functionality. It's just in a future iteration, we want it to look just like this. So with that, we'll go back to the main page and I'll show you how we would build a read book in this new application. We currently use PowerPoint and transition it over to a PDF file, but in here, we have a mechanism to just build the stories within the application. So we'll have a fillable form where we can produce our headings, upload a photo, select which model we want it to be from, have a subheading, then write our synopsis with the analysis, include any tags, display the countries, and then we have assigned numeric values to the Robin and threat probability. So we can enter those and it will automatically generate our threat matrix. So once I hit submit, it will be published to the screen. So again, we have the latest story here that we just published with the threat matrix available for viewing. And additionally, we can share these events with others. So we can enter any email addresses or create distribution lists within the application in order to send to those we wish to share with. In addition to that, because our stories have graphics with them, we have a text-only option for those who may have low bandwidth and not be able to download full photos or graphics. So once I hit send, that'll give you an example of what a text version of a story would look like with the alert levels with the corresponding threat. Okay, so now we'll go over an example from the chat function. This feature is so users can ask direct questions to Alchemy analysts about various things. So this is a question about the slide that we went over in the briefing about the lengthened runway of the airbase, asking what's the impact of the strategic air capability from that airbase. So in doing external research on the matter, we were able to find additional information on the significance of strategic bombers being able to fly out from that airbase. So I was able to respond to the chat question, and then individuals who have accounts in the system will be able to receive emails showing that there's an update in the system, which I have done. So this update shows the location of the airbase in the new graphic we published, and then includes data that we've researched to show the impact that it would have in that region of the world. So on average, each strategic aircraft would have one less refueling in order to fly from that airbase to our East Coast in the US. So that is the overall impact of reducing the resources needed to get to our borders, and also in the ability to increase dwell time over the northern part of the Atlantic Ocean.
So that concludes our demonstration of the Robin CBRN PAI CBRN IEW system.